Because we don't get a calculator on the MCAT math ends up being more about applying logic than it is about doing arithmetics. Let me show you what I mean. A solution contains 10 molar formate and 20 molar formic acid. What is the pH of the solution after the addition of 10 molar NaOH? So first of all, let's consider what happens to the conjugate base and the acid respectively after the addition of NaOH. So as you can see, we started off with 10 molars of the conjugate base and 20 molars of the acid. Once you add NaOH, because this is a buffer solution, that NaOH will deprotonate the acid, thus converting it into the conjugate base. And because we're adding 10 molar, it's going to convert 10 molar of the formic acid into formate. So now the new concentrations we have are 20 molar of formate, the conjugate base, and 10 molars of formic acid, or the acid. Now here's where the logic comes into play. Instead of trying to plug these numbers into the equation and do logarithmic calculations, just consider the fact that the pKa of a weak acid is generally going to be in the range of 3 to 4, maybe up to 5. And because we are adding base to this solution and increasing the amount or the concentration of conjugate base relative to the acid, the pH of the solution is going to be a little bit slightly above the pKa value. So we can cross out answer choice B. We can also cross out answer choices C and D. And here's why. If we consider, without even knowing the pKa value of formic acid, we can draw on our knowledge of how buffer solutions work, and that is buffer solutions tend to be resistant to changes in pH, so they won't deviate far from their pKa value if you're adding NaOH, a strong base, or HCl, a strong acid. So here we can assume that the pH is still going to be close to that pKa value, which is going to have to be an acidic value. So the correct answer here will likely be answer choice A.